One thing I did not mention in the last video, also on the right, besides having the count here displayed, and notice on the left was count over here, we do have the proportions already calculated for us, and notice all the proportions do add up to 1, as we had mentioned before. So to summarize with the one variable, we want to look at proportions. We can look at a frequency table. We can also look at a relative frequency table, where the frequency table, remember, has counts in it. The relative frequency table only has the proportions. When we're visualizing it, we can either do a bar chart or a pie chart. So let's go ahead and take a look at two categorical variables. So we want to look at the relationship between two categorical variables. So we're going to go ahead and collect some data from some university students on their relationship status and their gender. That data is displayed here in this table. So in a relationship, there were 32 females that said they were, 10 males said they were, for a total of 42 students in a relationship out of a total of 169. It's complicated is in this row going across here. It's single, or their single is in this one going across here. Now, in this case, I had the male and the female at the top. I could have basically had this chart flipped, and I could have had male and female over here, and along the top I could have had in a relationship, it's complicated, and it's single. But notice the last column and the last row are always going to be your totals. So, what proportion of students are in a relationship? Well, we need to take a look at total number of students in a relationship over the total number of students. So we get 42 over 169, or about 25%. When we're looking at the proportion of females in a relationship, well, then we need to look at only the females that are in a, which is 107, and those that are in a relationship is 32. So proportion of females, we got to look only at the female column. In a relationship, female in a relationship is 32 out of the total number of females. Now, as we look down below here, we want to look proportion of students in a relationship that are female. That is 32 out of 42. You need to look at proportion of students in a relationship, so we got to look only at those in a relationship, which is this row going across here. There were 42 total, and of those 42 total, 32 were female. And so we went 32 out of 42. Down below here at the bottom, we want the proportion of males in a relationship. We had males, which is 10 in a relationship out of the total number of males, which is 62. Now, make note that the proportion for number 2 and number 3 are totally different. One is 30, one is 76. So don't make the mistake that thinking the proportion of females in a relationship is the same as the proportion of students in a relationship that are female. So you got to make sure you're looking at the right column or row for your given information. And that's what this here is saying. So when we're looking at males and females, the females that said they were in a relationship was about 30%. The males was 16%. Why are they different? Well, there's several options. One of them could be males and females view whether they're in a relationship or not differently, as in a female might think she's in a relationship, but the male that she thinks she's in a relationship with doesn't necessarily view that the same way as a relationship. It is possible there could be some same-sex attraction relationships going on here, so that could make some of the difference. So let's look at the difference in proportions. So if you look at the proportion of one categorical variable and subtract it from the proportion of another categorical variable, you get the difference in proportions. So if we wanted to look at the proportion of females in a relationship compared to the proportion of males in a relationship, we'd take the proportion of females. Notice this is from our sample, so it's got a hat on it. We had figured that out before to be 30% or 0.3. The proportion of males was 0.16 or 16%. If we're looking at the difference, we're going to subtract those two proportions and we get 0.14 or 14%. So for this same situation, let's look at the proportion of students in a relationship who are female and the proportion of single students who are female. So if we look at that, we're going to go, once again, we have hats here, so we're dealing with our sample. Proportion of students who are in a relationship who are female, so relationships, so that's 42. Of those, 32 are females. So that's where we get the 32 over 42, and that's our 0.762. Then we need to go ahead and take a look at those that are single, which is 108, and we wanted those that were female and single, that was 63. So we want 63 over 108, and that's our 0.583. If we subtract these two three decimal numbers, that's where we come up with our difference in proportions of 0.179. Now, how do we visualize some of this data? Well, one way to do it is with the side-by-side bar graph. Now, in a relationship, we had female and we had male. Female is the darker bar, male's the lighter bar, and that's given to us by our key up here. There were 32 females in a relationship. There were 10 males in a relationship. So the height of each bar correlates to how many were in that spot on our table. It's complicated, the heights of our bars, and remaining single, the heights of the bars for each one. Now, instead of having side-by-side bars, we could have a segmented bar where in a relationship, in the dark is the female, and that went up to 32. And then there were 10 males on top of that, so the height of this lighter bar on top is a height of an additional 10. So the height of this whole bar, dark and white, is how many total were in a relationship, with the top part being the males and the bottom part being the females. Similarly for its complicated and similarly for its single. So consider this situation. Pause the video, read through this. Now we want to go ahead and make a two-way table for this. So that's what we're going to do on this next page. So we know there's a total of 67,000. It did say that half received the one drug, half received the other drug. So if we take half of 67,000, we end up getting 33,500. So each one of these needs to be 33,500. Now, we know that 58.7% survived for this drug here. So we need to take 0.587 and multiply it by the total there, and that's going to tell us how many we get in this column. Now, this 19,665 plus this one here needs to give us a total. So if we go ahead and take our total of 33,500 and subtract our 19,665, we end up getting this number here. Now when we look at the other drug, we knew that 55 or 51.5% survived. So if we take 55.5% of this, or 515 times 33,500, we get this one here. Once again, if we go ahead and subtract these two numbers here, we're going to get how many died. Now that we have this information, we can go ahead and do our total for those that survived. So we can add our 17,252 and our 19,665 together to get this one down here. Similarly, we'll add these two together to get this one down here. Now, if we would add across here, these two right here, all that survived and all that died should still add up to our total. So that's another way you can double check your numbers. So, two categorical variables. You want to make a two-way table. You can look at differences in proportions. For visualizing it, you can do a side-by-side bar graph, a segmented bar graph, and that's the end of this lesson.